Production and operations management focuses on how organizations design, manage, and improve the processes that convert inputs such as materials, labor, and technology into finished goods and services. This chapter introduces the structure of operations and manufacturing systems, explaining how processes, workflows, layouts, capacity, and resources come together to create value efficiently. It highlights the role of planning, scheduling, inventory control, and quality management, showing how these functions ensure reliability, cost control, and consistent output. Understanding these foundational elements enables organizations to streamline production, reduce waste, and respond effectively to customer demand. Operations management is the discipline that focuses on designing, planning, controlling, and continuously improving the processes used to produce goods and services. It ensures that resources such as materials, labor, machines, and information flow in a coordinated way to meet customer demand. For example, an automotive plant planning a daily output of 500 cars must align component availability, workforce capacity, and supplier delivery schedules. In practice, OM covers key activities such as forecasting and production planning, sourcing necessary materials, transforming inputs into finished products, managing logistics and distribution, and driving ongoing improvements to reduce cost, waste, and cycle time. The core functions of operations revolve around designing the goods and processes that shape how work flows, planning and scheduling production to balance demand with available capacity, and managing quality to ensure every product meets required specifications. They also include maintaining inventory at optimal levels enough to support production without creating excess and driving continuous improvement to enhance efficiency, reduce defects, and strengthen overall operational performance. The objectives of operations management focus on producing goods and services at the lowest possible cost, meeting quality specifications consistently, delivering with speed and reliability, adapting quickly to changes in product mix or volume, and ensuring dependable performance against commitments. These goals are tracked through metrics such as unit cost, OEE, defect rates, yield percentage, lead time, changeover time, and OTIF performance. A practical example comes from Toyota, which anchors its operations around just-in-time and Jidoka, enabling low inventory levels, high quality, and strong responsiveness to customer demand. The objectives of operations management focus on producing goods and services at the lowest possible cost, meeting quality specifications consistently, delivering with speed and reliability, adapting quickly to changes in product mix or volume, and ensuring dependable performance against commitments. These goals are tracked through metrics such as unit cost, OEE, defect rates, yield percentage, lead time, changeover time, and OTIF performance. A practical example comes from Toyota, which anchors its operations around just-in-time and Jidoka, enabling low inventory levels, high quality, and strong responsiveness to customer demand. The hierarchy of production plans organizes decision-making across 3 levels. At the strategic level, long-term plans covering 2 to 5 years address major issues such as capacity and facility planning. The tactical level focuses on the medium term, typically 6 to 18 months, where organizations prepare aggregate production plans that balance demand and available resources. The operational level manages the short term, from daily to monthly horizons, producing detailed outputs like the Master Production Schedule MPS and shop floor schedules. Together, these layers ensure coherence between long-range goals and day-to-day execution. Effective production planning and control improves on-time delivery and strengthens customer satisfaction by ensuring that production flows without disruption. It enhances capacity utilization, reduces work in process, and lowers inventory carrying costs by aligning materials, machines, and schedules precisely with demand. With smoother operations, organizations face fewer last-minute expedites and firefighting situations. A strong example is Maruti Suzuki, where advanced PPC practices and tight supplier coordination enable the company to maintain more than a 95% line fill rate while keeping planned inventory to a minimum. Production systems can be classified by the type and volume of output they handle. Job shop systems produce highly customized, low-volume items such as aircraft engines, while batch systems manage medium volumes of similar products like those in bakeries. Assembly line or flow systems operate at high volume with standardized items such as automobiles, whereas continuous systems run non-stop for products like petroleum or cement. Project-based systems handle large, unique outputs such as ships or major infrastructure, where work unfolds in distinct phases rather than repetitive cycles. The product process matrix illustrates how production processes align with product volume and variety. Job shops handle low volumes with very high variety and exceptional flexibility, while batch processes operate at medium volumes and moderate variety with balanced flexibility. Flow processes support high volume, low variety products and offer limited flexibility, and continuous processes run at extremely high volumes with minimal variety and very low flexibility. This alignment helps organizations choose the right process structure for efficiency and competitiveness. Process choice depends on factors such as product variety and volume, the required level of automation, and the degree of market volatility and customer expectations. Companies adapt their systems accordingly. For example, Samsung uses a hybrid approach with highly automated assembly lines for smartphones while relying on flexible batch processes for producing specialized components, allowing both efficiency and responsiveness in a dynamic market. Operations can become a powerful source of competitive advantage when an organization uses them to achieve superior cost efficiency through lean practices and automation, deliver consistent quality through approaches like Six Sigma and TQM, respond quickly to market shifts with agile and flexible production, and innovate through smarter process and product design. These capabilities allow companies to stand apart in crowded markets. A well-known example is Dell's build-to-order model, which enabled the company to assemble and deliver PCs faster and at lower cost than traditional competitors, turning operations into a strategic differentiator. Operations strategy ensures that a company's business goals are translated into the right manufacturing capabilities. When the goal is low cost, operations focus on lean processes and high utilization. For differentiation, they emphasize product innovation and customization. For fast delivery, they rely on agile planning and local sourcing. And for quality leadership, they strengthen systems such as TQM and ISO 9001. A strong illustration comes from Tesla, where close integration between R&D and manufacturing shortens the innovation cycle and gives the company tight control over product quality, aligning operational capability directly with strategic intent. Operations sits at the heart of the broader supply chain, and the real objective is end-to-end value creation rather than isolated departmental efficiency. Its integration points stretch across procurement and material planning, where inputs are secured, production scheduling and logistics, where goods are made and moved, and sales and operations planning, which aligns demand with capacity. Effective operations also depend on tight synchronization of inventory and demand so that materials flow without excess or shortages. When these links work together, the entire supply chain becomes faster, more responsive, and more economical. Vertical and horizontal integration strengthen how operations connect across the value chain. Vertical integration aligns an organization with its upstream suppliers and downstream customers to create smoother flows, better coordination, and shared visibility. Horizontal integration focuses on standardizing practices across plants, functions, and processes so the entire system operates with consistency and efficiency. A strong example comes from Toyota's Keiretsu network, where strategic supplier partnerships include sharing design information, production forecasts, and long-term planning, creating a tightly linked ecosystem that supports quality, reliability, and mutual growth. Technology acts as a powerful integrator by connecting every layer of operations and the supply chain. Airbnb's systems create a seamless bridge between planning and execution, ensuring that schedules, materials, and shop floor activities stay aligned. IoT, cloud platforms, and advanced analytics bring real-time visibility, allowing faster and more accurate decision-making across production and logistics. A strong illustration comes from Siemens, where the use of a digital twin synchronizes design, manufacturing, and supply chain operations, cutting new product launch time by nearly 25% and demonstrating how digital integration accelerates performance.